Hi everyone and welcome back. We're looking at rectangular prisms. We're going to start off with drawing the net of a rectangular prism. The question says draw and label a net to represent the rectangular prism. Let each grid unit represent 1 inch. That means each block, in this grid represents 1 unit. Right, so we're going to start off. This is the rectangular prism. And a rectangular prism, actually, if you look at it carefully, it actually has 6 rectangles in it. And we're going to look at them one by one and draw them. So we know we're going to have to draw 6 rectangles. So let's start with the first one. The first one, if you look at, is the top rectangle. This one here that I'm highlighting in green. That's the top rectangle. Okay. And to get, you can see there's no numbers on the top, so we don't know what the dimensions are. We need to figure out what the dimensions are by looking at the opposite sides. We know opposite sides are equal, so if this dimension we don't know is opposite this dimension, we can see this dimension is 3, so we know that the length here is 3 as well. And then to find the width of the top rectangle, you can see it's opposite to this dimension, which is 5. So it's 3 by 5. So going left to right, 3. 1, 2, 3. And then from top to bottom coming down 5 units. So that's the top rectangle, 3 by 5. Okay, that's the top. Right. Then next to it, below that, connected to the top rectangle, right? So it's connected, that means it's going to start from here. You can see is the front rectangle. We call this the front because it's right in front. This is the front rectangle, and the dimensions you can see are 3, and this dimension you can see is not given, this dimension here, but it's opposite this dimension, so you know it's 3 by 2. So this dimension here is 2, so it's going to be 3 by 2. This is already 3, and so we're going to fill in the 2 there. So the dimensions are 3 by 2, and that is the front rectangle. Right, then connected to this front rectangle, now continuing from this bottom part of the front rectangle, is this rectangle here, which is right at the bottom, and we call this the bottom rectangle. And the bottom and the top are exactly the same. It's 3 by 5. So we're going to continue from this part of the front rectangle, which is 3 units, and it's 3 by 5. So 1, 2, 3, 4, 5. So this is 3 by 5, and this is the bottom rectangle. And you can see I've drawn the bottom and the top rectangle the same color because they are opposite each other. They are exactly the same size. Right, then continuing from that bottom part, from the last part of the bottom of the rectangle, which is from this part here, you can see is this back rectangle here, right at the back. Right, that is the back rectangle. Now the back rectangle is exactly the same as the front rectangle because they are opposite each other, and we know the front rectangle was 3 by 2. So remember, 3 by 2. So even the back will also be 3 by 2. So continuing from here, from the bottom rectangle, 3 by 2. And it's going to look exactly the same as the front rectangle that we drew on top. Right, this is the back rectangle. So you can see the front and the back are exactly the same. So that gives us 4 rectangles. We're now left with 2 more rectangles to complete. So I'm just going to erase this so that we can see the 2 side rectangles more clearly. Right, so you can see there's 2 rectangles that we did not look at, and that is the side rectangle. So this is the side on the right hand side, right? And you can see they are connected to the front of this rectangle here. The front, remember this was the front rectangle, so I'm going to connect them to the front. This is 2 units, so the dimensions of the side rectangles are 2 by 5, so 1, 2, 3, 4, 5. Okay, so this is the right side, and then there's on the left side here, in an identical triangle to the right side. So if the right side is 2 by 5, then the left side will also be 2 by 5. Okay, and that gives us the 5 rectangles of the rectangular prism, and that makes up the net. This is what we call is the net of the rectangular prism. In other words, if you open up the rectangular prism, this is what it would look like. All right, or if we fold up this net, then it would give us the rectangular prism. All right, we're going to move on to the next part of this section, which is calculating the surface area of the rectangular prism. Now remember, we said the rectangular prism has 6 rectangles. So surface area means the total area of all the 6 rectangles. We're going to add them all up together. So let's start. Right, you can use one of these two. This is the rectangular prism that you're given here first, and next to it is the net. So you can just use the net if you want to find the surface area, which is the areas of all the rectangles. So you can start with the first rectangle here. The first rectangle here, remember, area for rectangle is just length times width. So you can see the dimensions are 20 by 10. So the area of this triangle is just 20 times 10, which is 200. So when I'm working out total surface area, we know that now in the rectangular prism, remember we said that there are 2 pairs. Every rectangle has a matching rectangle, right? If you go back to the previous question, you can see the top rectangle here had the same dimensions as the bottom rectangle, and the front rectangle was the same as the back rectangle, and the left side was the same as the right side. So similarly, when you're finding the surface area of a rectangle, of a rectangular prism, it means that if you find the area of one of the rectangles, then it means the other rectangle is also going to be, there's going to be a matching rectangle, right? So if that one is 200, then the total surface area will be 200 plus another 200, right? Right, and the matching rectangle will be one rectangle away. So this would be the matching rectangle. And you can see here that although the dimensions, you do not see it here, if that dimension is 20, then it means that all these dimensions are 20 as well. So this is the matching rectangle for it, 20 by 10. So you can see here also in these 2 rectangles will have the same area, 20 by 10, 20 times 10, which is 200. Okay, so here as well you can see area is equal to 20 times 10, which is 200. Right, let's go to the next one. If you look at this rectangle here, you can see here there's none of the dimensions are given, so we're going to have to figure it out. So let's look at that. This dimension is going to be the same as that dimension, which is 20. So we know this dimension is 20. And then this dimension we don't know, but we can see it's opposite this dimension, which is 12. So that's how we know that this dimension will also be 12, because opposite sides are equal. So the area of this rectangle will be 20 times 12. And you know 2 times 12 is 24, and with that 0 is 240. All right, so we're going to get another rectangle that's 240. Now you know two rectangles will be 240, so this will be the rectangle that will also be 20 by 4, because although this dimension is not given, you know it's the same as that dimension, which is 20, and this dimension is given as 12, so the area here is the same. It's also 20 times 12, which is 240. Right, so we know we're adding in the areas of the two rectangles of 240. Right, if we go next to the side rectangles, you can see the right side. Here the dimensions of the right side, you can see, is 10 by 12. Okay, so the area here will be 10 times 12, which is 120. So we know we're going to add 120 two times, because even the left side will also be identical to the right side. The area here will also be 10 times 12, which is 120. Remember, this is the left side and this is the right side. They are matching each other. So now I have my 1, 2, 3, 4, 5, 6 rectangles. I can now add them up to get the total surface area. So 0, 0, 0 will give me 0 here, and then 4 and 4 is 8. 4 and 4 is 8, plus 2 is 10, plus 2 is 12, 2 carry 1, and then 2, 4, 6, 8, 9, 10, plus that 1 is 11. So my total surface area is 1120 centimeters squared. Right, and that's how we calculate total surface area. Let's do one more example. Right, in this question, it's exactly the same as the previous one, except now we have like decimal numbers here. So let's read this question. Trey is using cardboard to construct, means to make something or to build it, to construct building blocks that are shaped like rectangular prisms. Use the net to determine the minimum amount of cardboard he will need to construct one block. So the amount of cardboard that you need to make, that actually means how much you cover something or you make something. They're actually talking about surface area. So that's your keyword. Right, let's start. Here you can see the first rectangle here. The dimensions are 3.2 by 3.2. So the area of this rectangle will be 3.2 times 3.2. And let's work that out. So 3.2 times 3.2. So first we're going to ignore the decimals. 2 times 2 is 4. And then 3 times 2 is 6. And then for the 3, that's 32. So you're going to put that 0 down first. And then 3 times 2 is 6. And 3 times 3 is 9. Adding them up, 4, 6 and 6 is 12. 9 and 1 is 10. And you can see 3.2 has one number after the decimal point, and this 3.2 also has one number of the decimal point. So that means in total our answer will have two numbers after the decimal point. So the area here is 10.24. Okay, now remember we said there'll always be two matching rectangles opposite each other that will have the same area. And you can see this dimension is also 3.2, right? That dimension is 3.2. And this dimension will be the same as this dimension, which is 3.2. So you can see that this area here is the same. It's 3.2 times 3.2, because this dimension is 3.2, which is 10.24. Okay. So when we're working out total surface area, we're going to add the 10.242 times Now we're going to look at the next rectangle. Let's look at this one here. If you look at this rectangle here, so you can see this dimension is 3.2, and we want to find what is that dimension. So this dimension we know is 3.2 because it was opposite this dimension, and this dimension is opposite that dimension, which is 3.5. That means this is 3.5. So the area of this rectangle will be 3.5 times 3.2. So we have to do that calculation now. 3.5 times 3.2. So we're first going to multiply like 35 times 32. 5 times 2 is 10. 3 times 2 is 6, plus that 1 is 7. Now for the 3, that's actually a 30. So we're going to add that 0 first. 3 times 5 is 15. 5 carry 1. And 3 3s are 9, plus 1 is 10. We're going to add these up. 0, 12, 1, 1. Okay, so and then you can see there's one number after the decimal point in the 3.5, and in the 3.2 there's one number after the decimal point. So in my answer there'll be two numbers after the decimal point. So we know that area is going to be 11.20, and we're going to add it 2 times because every rectangle has a matching rectangle in the rectangular prism. So this rectangle you can see is also 3.5 by 3.2. So this area will be 11.20, and this area will also be 11.20. Right, then for the last rectangle, you can look at the sides. You can see this rectangle, the dimensions are 3.5, and this dimension here is 3.2. So the area will be 3.5 times 3.2. Now you can see we've already done this calculation. It's also 11.20. So this rectangle will also be 11.20. And the other side rectangle, which is its matching side, this area will also be 11.20. So we're going to add the 11.20 2 times and find our total surface area. Right, let's add that up all together. Right, so we're going to have 4 and 4 is 8. And then 2, 4, 6, 8, 10, 12. 2 carry 1. And then 1, 2, 3, 4, plus that 1 is 5. And then 1, 2, 3, 4, 5, 6. So 65.28 square inches is the total surface area of this rectangle. Okay, and that's how you calculate surface area of a rectangular prism.